All right, welcome to another deep dive. Today, we're going deep into databases,
Databases, yeah.
the foundational stuff.
Yeah.
And the material you sent over is great CRUD operations, create, read, update, and delete, right?
hmm
Plus, like how to actually get the info you need with queries. So I guess our mission today is to really break down these concepts, show everyone why this is the backbone of how information is managed.
Absolutely, yeah.
Pretty much every system you use every day relies on this stuff.
Like, it's everywhere. You can't escape it.
No. And we'll also be covering some techniques for filtering, sorting, even limiting that data you get back.
Yeah.
And we'll highlight some common mistakes, so you don't accidentally delete your entire database.
Yeah, definitely. Don't do that.
Avoid those data disasters.
Understanding CRU'd and basic queries is
Ah,
it's the foundation, you know? Think of it like grammar and vocabulary. You need it to actually speak the language of data. It doesn't matter if you're working directly with databases or you're just trying to understand how that app on your phone
like
works.
all data underneath, right?
These concepts are in play everywhere.
Okay, so let's jump right in. CRUAD. I mean, it sounds kind of techy, but it's really just the 4 essential actions you can do with data. First up, we've got create. Pretty self-explanatory, right? It's how you add new info into your database.
It's like adding a new file to that, that super organized digital filing cabinet.
Perfect analogy. And the standard way to do this is SQL. That's structured query language, right?
Right.
The most common way to talk to databases.
Right.
And you use the command insert into. The syntax looks like this, and I know we've got some visuals for our viewers. Insert into table name, and then in parentheses, column 1, column 2, and so on. And then values, parentheses again, value 1, value 2, and keep going for each column. So let's make this really clear with an example. Imagine we've got a table called employees. It's got columns for employee, name, and department. So let's say we're adding a new employee, John Doe. He's in sales. Employee ID is 1. The SQL command would look like this. Insert into employees, in parentheses, employee, name, department, close parentheses, valuees, parentheses 1, John Doe, sales, close parentheses, and semicolon.
Boom, John Doe is in the system.
Exactly. So that insert into employees bit tells the database which table we're adding to. Then in the parentheses, we list the columns we're filling in.
Right.
Employee ID, name, department. And the valuees is followed by the actual data. Just got to make sure the order matches the columns.
Yep, got to keep it organized. One thing that trips people up sometimes is the data types. Remember, the database is expecting specific types of data for each column.
Like text versus numbers, right?
Exactly. So employee might be set up for numbers only, name would be text, department would be text as well.
Makes sense. You got to make sure the data you're inserting matches what the database is expecting.
Yeah, otherwise things can get messed up. It's all about accuracy and reliability, You don't want your data turning into a jumbled mess.
No, definitely not. Okay, so we've created our entry. Now we want to actually see it. That's where read comes in. Or in SQL terms, select.
Select, yeah. It's how you get information out of that database.
It's what you're doing constantly, whether you're running a report or you're just looking at data in an app. It's all select.
It's happening behind the scenes all the time, pretty much.
Yeah.
The basic syntax for a select query is select column 1, comma column 2, and so on from table name. So you're telling the database which bits of information you want.
Right, the columns.
Yeah, and where to get them from. That's the table.
Okay, so if we want to just see the names and departments of all our employees, it'd be select name, comma, department, space, from employees.
Exactly. And that would give you a nice little table with just the names and departments.
And if you want everything, all the info in the table, you can use that asterisk.
The trusty asterisk. It's like a shortcut to grab it all. So select from employees.
Simple as that. But there's a catch.
There's always a catch, right?
Right.
While select can be handy, especially when you're first exploring a data set, it's generally best practice to just list the columns you need.
Okay, so be more specific.
Yeah, like imagine you're at a restaurant. It's more efficient to just tell the waiter what you want instead of saying, bring me everything.
I like that analogy.
Right. It's the same with databases. Listing the columns just makes things clearer. Your queries are easier to understand, and it can actually be faster, too.
Makes sense. The database doesn't have to fetch all that extra data you don't even need.
Exactly. Especially with those huge databases, those extra milliseconds can really add up.
So efficiency is key.
Absolutely.
Okay. Moving right along to update. This is how you change existing information.
So John Doe gets a promotion, changes departments. You got to update that record.
Exactly. And the syntax for that is update table name set column 1, value 1, comma column 2, value 2, and so on. Where condition.
Ah, the where clause.
It's back.
So important. Without it, you're updating everything.
Yeah, you don't want to do that unless you mean it.
Really, really don't want to do that. So let's say John Doe moves to marketing. The command would be update employees, set department marketing, where employees 1.
So that update employees part tells us which table. Set department marketing changes the department, and the where clause makes sure it's only John Doe's record that gets updated.
It's like your safety net. Always double check that where clause, especially with updates and deletes.
Right, because forgetting it could lead to some pretty big problems.
Yeah. You could accidentally change everyone's department to marketing.
Okay, yeah. Last thing you want. So let's talk about D, delete, the final piece of the CRUD puzzle.
This is how you remove information from the database. Bye-bye, data.
And as you might guess, the syntax is delete from table name where condition.
That where clause is back again. I can't stress it enough. Be careful with deletes.
All right, so if John Doe leaves the company, we need to remove his record. It'd be delete from employees where employee due 1.
Gone. Poof. Just like that. But seriously, double, triple check those conditions before you hit enter.
Couldn't agree more. Okay, so we've covered CRUD. We can get data in, get it out, change it, remove it. But what about actually working with the data, making sense of it?
That's where querying techniques come in. Think of it like, you've got this massive library.
Yeah.
CRUD is like adding books, finding books, changing them, getting rid of them. Querying techniques are how you find the exact book you want.
Based on title, author, genre, all that.
Precisely.
Okay, so let's dive into some of these techniques. First up, we've got filtering data with where. We've seen it already, but it's essential for selecting specific data that meets certain conditions.
Right. So for example, let's say you just want to see the employees in sales. You would use select from employees where department sales. That where clause is your filter.
Like searching on Google, but for your database.
Exactly.
So next up, we've got sorting data with order by why. This lets you arrange the results, make them easier to read or analyze.
Yeah, you can sort them alphabetically, by date, by number, whatever you need. The syntax is select column 1, comma column 2, and so on, from table name order by Y column to sort B. And then you can add ASC for ascending or DSC for descending.
So ASC would be A to Z, smallest to largest. DSC would be Z to A, largest to smallest.
Right, and if you don't specify, it usually defaults to ascending. So select from employees, order by name would list all our employees alphabetically.
Easy. And then we have limit. This one lets you restrict how many rows you get back.
Super useful for those massive tables where you don't need to see everything. Like, just give me the top 10 results or something.
So the syntax is select column 1, comma column 2, etc. from table name limit number of rows. So to see just the first 10 employees, it'd be select from employees limit 10.
Yep. And you can combine limit with order by 2. So if you wanted to find, say, the top 3 highest earners, you could order by salary in descending order and then limit to 3 rows.
Powerful stuff. Now, sometimes a single condition isn't enough. That's where and or come in.
Combining conditions, yeah. So with and, both conditions have to be true. It's like saying, I want employees who are in sales have a salary over $50,000.
So the query would be select from employees where department intakes sales and salary 50,000.
Exactly. And with R, at least one of the conditions has to be true. So like, I want employees who are in sales or in marketing.
So select from employees where department sales or department marketing.
You got it. You can even get more complex with parentheses, just like in math. Control the order operations.
I'm starting to see how powerful this can be.
Oh yeah, the possibilities are endless.
Okay, another handy one is distinct. This is for when you want to see only the unique values in a column.
No duplicates, just the unique stuff.
So the syntax is select distinct column name from table name.
So if you wanted to see all the different departments, you'd use select distinct department from employees. You'll get a list of departments, and each one will only appear once, even if there are tons of employees in that department.
All right. Now let's bring it all together. Real-world example time. Let's say you want to find the top 5 highest paid employees in sales. How would you do that?
All right, so let's break it down. We want name and salary.
Okay.
Then we need a where clause to specify sales. We want to sort them by salary, highest to lowest, so that's order by salary des C. And finally, just the top 5, so limit 5. Put it all together, it's select name, salary from employees where department equals sales, order by salary des limit 5.
Oh, there you have it.
You've got your top earners in sales.
And all with just a few lines of SQL.
That's the beauty of it.
Now, before we wrap things up, let's touch on some common mistakes people make. Things to watch out for.
Gotta avoid those pitfalls.
Definitely. I think we've hammered this home, but forgetting the where clause in updates and deletes is a big one. Always double, triple check that you're targeting the right rows.
Seriously, it can be disastrous. Also, another common one is using select when you don't need to.
Right. Grabbing everything can really slow things down.
And it makes your code harder to understand. Just list the columns you need. Keep it clean, keep it efficient.
Another thing is indexes. Now, we won't get into the details here, but they can really speed up your queries.
It's like having an index in a book. Makes finding things much faster.
But don't go overboard with indexes either. Too many can actually slow down other operations.
It's all about finding the right balance.
And data types. Always make sure the data you're inserting matches the column type.
Yeah, like don't try to put text into a number column. The database won't be happy about it.
And finally, always test your queries, especially those updates and deletes.
Please test your queries. Use a test database, a small sample, anything. Just don't run it on your live data until you're absolutely sure it does what you want it to do.
So you're saying it's better to be safe than sorry.
100%. Now, on the flip side, let's talk about some good habits, some best practices for writing better SQL.
Okay, I like that. So first up, clarity is key. Write readable SQL code.
Right. Use consistent formatting, indent your code, use meaningful names for your tables and columns. Make it easy for yourself and others to understand.
And comments. Use comments to explain complex queries, or just to remind yourself why you did something a certain way.
Your future self will thank you.
Absolutely. And while it's not directly related to writing queries, back up your database regularly.
So important. You never know when something might go wrong. A good backup can be a lifesaver.
All right, one final real-world example to bring it all home. Let's imagine we're running an online store.
Perfect. So we've got a products table,
Right?
columns for produced, name, price, stock, standard stuff.
So we get a new product, let's say a wireless mouse. It costs $29.99, and we've got 50 in stock. How do we add that?
All right, so that's our create operation. The query would be insert into products, parentheses produced, name, price, stock, close parentheses, values, parentheses 101, wireless mouse, 29.9950, close parentheses, semicolon.
Okay, so we've added our wireless mouse. Now,
Yep.
how do we see all the products that are actually in stock?
That's a read with a filter. We'd use select from products where stock 02, so we're only getting products where the stock is greater than 0.
Makes sense. Now let's put that wireless mouse on sale. Knock it down to $24.99.
All right, time for an update. We'll use update products, set price equal $24.99 tour, where produced equal 101. Remember that where clause is making sure we only change the price of the wireless mouse.
Right. Crucial.
Yeah.
And what if we run out of a product and decide to stop selling it?
Delete time. Delete from products where stock equals 0. That'll remove any products with 0 stock.
Again, be careful with that where clause.
Always. And finally, let's say we want to see our top 3 most expensive products.
Show me the pricey stuff.
We'll combine order by and limit for this one. So the query is select name, price from products, order by price, deci limit 3.
Perfect. So we're sorting by price, highest to lowest, and then just grabbing the top 3.
That's how it's done.
All right. I think that online store example really demonstrates how these operations and techniques are used in the real world. It's not just abstract stuff. It's how things actually work.
Absolutely. From social media to banking, these concepts are everywhere.
Now, let's do a little recap, quiz ourselves a bit. Imagine you're in a job interview and you get asked, what are SYNART operations and how do you use them in SQL? What would you say?
Well, I'd start by saying that CRUD stands for create, read, update, and delete. They're the basic operations for interacting with a database using SQL.
Right. And you'd probably give some examples of the commands like insert, select, update, and delete, right?
Definitely. Got to show them you know your stuff.
Next question. How do you filter data using the where clause?
Easy one. The where clause lets you specify conditions that rows have to meet to be included in the result. Like if you only want employees in a specific department, you'd use where department sales.
Okay. Now, this is a classic one. What is the difference between order by and group by?
All right, so order by is for sorting the results, putting them in a specific order. Group by is for grouping rows that have the same values in specific columns, often used with those aggregate functions like count or AVG to calculate stuff on those groups.
Good explanation. Next, how do you limit the number of rows returned in a query?
That's where limit comes in. Select from employees, limit 10 would give you just the first 10 employees.
All right, now for some common mistakes.
Sure.
What are some common mistakes to avoid when writing SQL queries?
Oh, there are a few. Forgetting the where clause in updates and deletes, that's a big one. Using select when you don't need to, not testing your queries before running them on your real data.
Good points. What about how do you retrieve distinct values from a column?
Distinct is your friend here. Select distinct department from employees would give you a list of all the unique department names, no duplicates.
Okay. Now, we didn't really cover joins today, but they often come up in interviews. What is the difference between an inner join and a left join?
So an inner join only returns rows where there's a match in both tables based on the join condition. A left join returns all the rows from the left table and the matching rows from the right table. If there's no match on the right, it'll just fill in with nulls.
Nice explanation. Let's move on to string operations. How do you concatenate strings in SQL?
Depends on the database system, but usually you can use the concat function or the operator. Like to combine first and last name, you could use select concat, first name, last name, as full name from employees.
Okay. What about pattern matching? What is the purpose of the like operator?
Like is for finding things that match a certain pattern. You can use wildcards like % to match any sequence of characters or to match a single character. Like select from employees where a name like J% would find all employees whose name starts with J.
And case sensitivity.
Hmm.
How do you handle case sensitivity in SQL queries?
Some systems are case sensitive, some aren't, but you can usually use functions like lower or upper to convert everything to the same case before comparing. Like select from employees where lower name John Doe.
All right, two more. What is the difference between having and where?
Okay, so where filters individual rows before any grouping happens. Having filters groups after they've been created by a group by clause. So where for individual records, having for groups of records.
And finally, a simple one. How do you count the number of rows in a table?
That's the count function. Select count. From employees will tell you how many rows are in the employees table.
Perfect. So those are some common interview questions. Now let's put it all into practice with a couple of scenarios.
Scenario time.
All right, scenario one. How would you retrieve the top 5 highest paid employees, regardless of department?
Easy. Select name, salary from employees, order by salary, desk limit 5. We're sorting by salary in descending order and then limiting to the top 5.
Perfect. Scenario 2. Let's say we've got an orders table with an order date column. How would you delete all orders placed before the year 2020?
Okay, so we need a delete statement with a where clause. It would be delete from orders where order date 2020-01-01. We're deleting from the orders table where the order date is less than the 1st of January 2020.
And remember, folks, always double-check that where clause before you hit enter. All right, so I think we've covered a lot of ground today. CRUD operations, the 4 essential actions for working with data.
Create, read, update, delete. The foundation of everything.
Then we went into some basic querying techniques, filtering with where, sorting with order by why, limiting with limit, combining conditions with and or, finding unique values with distinct.
And we even touched on some common mistakes to avoid and best practices to follow.
It's all about writing clear, efficient, and safe SQL code.
And always remember to back up your database.
Absolutely. So our next deep dive will be taking us into the world of joins and relationships.
We'll be building upon what we learned today, showing you how to combine data from multiple tables for more complex analysis.
It's going to get even more interesting. So if you have any questions about what we covered today, or if you have any suggestions for future deep dives, please reach out. Our contact info is in the show notes.
We love hearing from you, so don't be shy.
And until next time, keep exploring the amazing world of data.